In this video, I will show you how to solve for unknown values when you are looking at similar triangles. First, you got to match up your corresponding sides. So I see the x right here. That is ZC. Here's Z and here's C. That's the beginning and the end. That's going to correspond with AY. Here's AY up there. So those are corresponding sides. Okay, on the other hand, see that 21? That's BC. Here's BC right here. That corresponds with BY. Here's BY. These are corresponding sides. Now, pick one triangle to be considered new and the other one to be considered old. It doesn't matter which one you pick. If one of them has an X, I usually call that one new, but it doesn't matter. What matters is that you always write your equation in the form new over old equals new over old. So look at the yellows. New over old is going to be x over 19. Look at the blues. New over old will be 21 over 14. Time to cross multiply. This diagonal, if we multiply, gives us 14x, whereas this diagonal gives us something else, but I don't know what it is. 19 times 21 to the calculator. 399. 399. I wonder if this is going to divide in evenly. Let's find out. Divided by 14. 28.5. 28. All right, and that is how you find the unknown value. Let's keep going. Oh my goodness. Okay. So usually when we have overlapping triangles like this, one of the things I recommend that you do is to draw the triangles separately. So normally I would be going like this and say, hey, look, here's like, see the small triangle, everybody? Focus your eyes on that. Bam. Okay, there it is. And then I would take the large triangle and I'd do the same thing. Okay, this is what I usually do when I see that I have overlapping triangles. I draw them separately, and then I do the whole new over old thing like I did on the previous problem. But occasionally, we can do something better than that. And that something better is called the side splitter theorem. Side splitter. Okay, the side splitter theorem. And this is something that we can use when we're only dealing with the sides of the triangle. In a way, I'm looking at this as the base of the small triangle, and I'm tilting my head a little bit sideways, and I'm seeing this as the base of the large triangle. And notice how we're not dealing with either of those. It's all about the sides. So is only for sides, is for sides only. Okay, so because I have sides only, here's what we can do. Let's just look at the two sides of the triangle, and this will be the yellow side of the triangle, and this will be the blue side of the triangle. So instead of doing new over old is equal to new over old, we can just do yellow over blue is equal to yellow over blue. Okay, whoops, that's yellow does not start with a W. Okay, so, oh my God, I'm having a stroke, you guys. Call 911. So yellow over blue is equal to yellow over blue. So this is the side splitter theorem. So we can just use the side. So when I say yellow over blue, I'm talking about 15x over 24. So I can just do 15x over 24 equals. And then the other yellow over blue is going to be this and this. All right, messed that up a tiny bit. Okay. And this. So that's 40 over 16. All right, this is going to be much cleaner than if we drew the triangle separately, which would have been a little bit of a mess. So I encourage you to use the side splitter theorem anytime you're just dealing with the sides. So the rest is easy peasy, lemon squeezy. We're going to cross multiply. So 15 times 16 is 240. So that's going to be 240x. And then 24 times 40 is 960. And then we have to divide both sides by 240. X is equal to 4. Now that is not the final answer for this problem. Yes, we had to find x, but then we need to plug it in to find MP. MP. MP is both of these. Maybe that's too dark. Let me try green. MP is both of these together. All right, so in other words, MP is 24 plus 15x. All right, because MP is the whole way. So now that we know that x is 4, that means that MP is going to be 24 plus 15 times 4. Okay, so 15 times 4 is 60. So this is going to be 24 plus 60. So that's going to be 84. And that is the final answer. All right, let's do 2 more problems. Matching up the corresponding sides. All right, don't assume which sides correspond. Maybe the 8x minus 2 goes with the 12. Maybe it goes with the 20. We don't know is the point. So DE is right here. So DE is like the beginning and the end. That's going to correspond with HE. Okay, HE is right here. So turns out that these are corresponding. Sometimes it goes the other way. You have to use the similarity statement. Don't make assumptions. Now, you would figure that these other two are probably corresponding, but let's check and be sure. So here's GE, boom. That's corresponding with FE, boom. So that's the 12. Boom. Okay, now pick one triangle to be new and one to be old. It matters not which. I'm going to call this one new, and I'm going to call this one old. It doesn't matter which one you do, but make sure when you set up your equation, you do it in the form new over old is equal to new over old. Okay, let's do the yellows first. So new over old would be 8x minus 2 over 20. All right, time for the blues. New over old would be 5x minus 3 over 12. All right, now we cross multiply. Okay, so here's one diagonal. And we need to do the distributive property. Take this 12, and we're going to multiply it by each part here. Okay? So we get 96x minus 24. Now looking at the other diagonal, and again, make sure that you are doing the distributive property with that 20. So that's going to be 100x minus 60. Let's get these x's together by subtracting 96x from both sides. That's going to leave us with negative 24 is equal to 4x minus 60. Trying to get that x by itself, so let's add 60 to both sides. Okay, so that's going to leave us with 36. So 4x equals 36. And then if we divide both sides by 4, we get x is equal to 9. But that is not the final answer, because we're supposed to plug it in and find GE. So where's GE? GE is right here, you guys. It's the 5x minus 3. Okay, so GE is 5x minus 3. We know that x is 9 now, so that means GE is going to be 5 times 9 minus 3. So that means GE is 45 minus 3. So therefore, GE is 42. And that is the final answer. All right, last problem, you guys. Let's start by matching up corresponding sides. So DF is right there. That corresponds with BC, which is right here. So these are corresponding sides. So probably the 65 and the 39 are corresponding sides. But let's not assume things. This 39, that's DE. All right, here's DE right here. That's going to correspond with AB, and that is, in fact, 65. Pick one triangle to be new and one triangle to be old. It does not matter which is new and which is old, as long as you set up your equation in the form new over old equals new over old. Look at the yellows. New over old would be x plus 5 over 3x minus 13. Now look at the blues. New over old is 39 over 65. Time to cross multiply. All right, looking at this diagonal, I must do the distributive property. I'm going to take this 65 and I'm going to multiply it by x and 5. So that'll give me 65x plus whatever 65 times 5 is, 325. All right, now let's look at the other diagonal and another distributive property. I'm going to take this 39 and I'm going to multiply it by 3x and negative 13. Okay, so that's going to be 117x minus 507. Okay, let's get these x's together by subtracting 65x from both sides. So that'll leave 325 is equal to, whoops. Okay, so I've got 52x minus 507. Now let us add 507 to both sides. Okay, so I need to do 325 plus 507. $832. All right, I wonder if this will divide evenly by 52. Sometimes you're going to get a decimal of some kind, but it just feels satisfying when I get a whole number, so I'm kind of hoping. Whole number, boom, 16. Ah, that's nice. And that is it, because they only asked us to find x and nothing more.